So our first equation that we're going to do in this video is going to be x double prime plus 9x equals 0. I want to find the solution to x equals whatever, right? This has a characteristic equation of r squared plus 9 is equal to 0. That I would get by subbing an e to the rt in and then deriving a couple times and then dividing. But I think at this point you should see that you can jump straight from there to there. That gives me r squared equals negative 9, which gives me r equals plus or minus, I'll write this as root negative 9, which is root 9 times negative 1, which is 3, and then I. And all these have plus or minuses on them, like that. So my r is plus or minus 3i. From here, I'm going to use Euler's formula. I know x is equal to, I don't even have to write this. I'll tell you what I write in blue or in purple here, you wouldn't need to write. X would be equal to C1, I'll write A1 like we did in the last video, cosine A1 e to the 3it plus A2 e to the negative 3it. And then we would do a whole bunch of work with Euler's formula and get down to the spot where we would have A1 plus A2 times cosine of 3t plus I times A1 plus A2 sine of 3t. Remember the 3 comes from these guys. And then you would just convert that to C1 cosine 3t plus C2 sine 3t with some conjugate pair magic is what I'll call it. So you don't have to do that in purple. From here, just say, okay, plus or minus 3i. What do we get? We get C1, x is C1 cosine 3t plus C2 sine 3t. I may ask you at some point to show me that you can do this stuff, but in general, when you're solving these problems, once you get these imaginary components, bam, they pop right to sines and cosines. You don't got to do any extra work. You should understand that it comes from Euler's formula, and you should understand that math. But you can just jump straight to this. So if I were to give you this one, your work here would be the stuff that's in green. So let's do another one. The next one is x equals, actually before we do this, if we were in class, I would say x squared plus 2x plus 1. What does that factor to? You should be able to factor that. X plus 1 times x plus 1, which is x plus 1 squared. Notice this is something that factors down to something that is a square. That's because this 1 completes the square on this thing. So say I were to give you x squared plus 6x, and I asked you to complete the square on that. Well, what would you add? See if you can add the right thing there to make it so that it would look like this. Oh, we would add a 9. And why is that? Because that is x plus 3 squared. If I asked you to do x squared plus 10x plus something and asked you to fill in the something that would complete the square, you should know that we take this thing, we divide it by 2 to get 5, and then we square it. So I put a 25 there. So this is x plus 5 squared. So we use that a lot when we're doing these things. So now we can do example 2. Let me take x double prime plus 4x prime plus 13x is equal to 0. I want to solve this differential equation. So in order to do this, I do a characteristic equation, r squared plus 4r plus 13 is 0. Whatever my r values, those are going to go on my e to this. So this one, I'm like, can I factor it? Can I factor it? Can't figure out how to factor it. So I get r squared plus 4r, and then I write plus, and I'm going to write boink, and then plus, and then boink equals 0. And then I got to fill in these two boinks. What I mean by that is what goes here, so that I will have this section be a something that was that I could factor down to a perfect square. So complete the square on the 4r right here. Well, what do I need there? Divide 4 by 2. It gives me 2. Squared, I get 4. So this is going to factor to r plus, 2 squared. Now, in order to keep equality from this line to this line, or equivalence, I need to still have a 13 here. So the question is, what do I put here so that 4 plus this thing is 13? Well, if you choose a 9, then 4 adds to 9, or adds to 9 and gives me 13. So this is the same as r plus 2 squared plus 9 is 0. So that's called completing the square, which gives me r plus 2 equals squared equals negative 9. Square root r plus 2 is plus or minus 3i, and then move the 2 over, r equals 2 plus or minus 3i. So now what I'm going to do, change colors, come over here. This gives me x equals, I'll use a's again, a1 e to the 2 plus 3i times t plus a2 times e to the 2 plus 3i times t. And at this point, we're going to do some algebra. You should know that x to the 5th times x to the 10th is going to be x to the 5 plus 10, which is x to the 15th. So I'm going to separate some pieces. This is the same as a1 times e to this gives me a 2t times e to the 3it. All I did was distribute the t in, recognize that they were separated by a plus like this, and then separate them into two different things being multiplied. Plus a2 times e to the 2t times, I messed up there. That should be a minus 3i. So times e to the negative 3it. So from here, what I want you to see is that this term and that term are in both of them. So I can factor it out. So I can get that this is equal to e to the 2t, open bracket, close bracket. And the question is, what has to go in these brackets to make it so that this line is the same as that line? Well, I would need a1 e to the 3it plus b, plus a2 e to the negative 3it. Now what I want you to recognize is that this is exactly the same as what I had up here. a1 e to the 3it plus a2 e to the negative 3it. So what's that all go to? It just goes to sines and cosines with 3's on the inside, right? So this one was where I had an r equal to plus or minus 3i. Come down here, if I've got a real component to my r values, as opposed to just, this one just had an imaginary component, plus or minus 3i. This one has a real component, 2, plus or minus the 3i. That's really just going to pop out front and be a real exponential piece, right? E to the 2t. So all of this goes to sines and cosines. So I get e to the 2t times, I'll write my cosine first, c1. Remember, we'll do all this little magic conjugate pair stuff, right? With Euler's formula, C1 cosine of 3t plus C2 sine of 3t. So I am totally fine with you if you are comfortable with it, jumping from here straight to there. Anytime you see the imaginary piece, it just becomes sines and cosines. The rest of it is exponential, right? So you've got this exponentially growing combination of sines and cosines. Let's do one more. Let's do x double prime plus 5x. Oops, hold on. Here we go. This one will work. X double prime plus 10x prime plus 26x equals 0. And remember, I said this in the beginning, but we will contextualize this. We will make sense of this. We will add it to all kinds of contexts. But for now, we're just learning how to solve the differential equations. So, all right, r squared plus 10r plus, what would I complete the square? 25, right? Divide 10 by 2 and square it is 25, plus another 1 is equal to 0. So this gives me r plus 5 squared is equal to -1 if I move that guy over, which gives me r plus 5 is equal to plus or minus I, which gives me r equals -5. Did I jack something up here? Oh man, negative. Sorry. Negative, 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 negative. Dearest apologies. So, come down here, plus or minus I, which that then goes and gives me, you can jump straight to it if you want. X equals e to the -5t. That comes from this, the real part, and then sines and cosines with that as the frequency coefficient. So times cosine, whoops, I need my c's, c1 cosine of t in this case, because the coefficient here is just 1, plus c2 sine of t. Close. Bam. That's the solution to that thing. And I'm fine with you doing, like, this is your minimum amount of work, unless you can do some of this algebra a little bit more quickly. So hope that demos how to do these 3 problems. And I apologize for messing up my negative here. So that's all. There it is.